if you're solving for an exponent, up till now, we could only do this if they were on our powers chart in the same column. Then we could do it without a calculator and solve it. But if it wasn't in our powers chart, the best we could do was use a graphing calculator or Desmos and graph both sides and see where they intersect. Now on your exam, they're going to give you a calculator, but not a graphing calculator, and say, can you still solve this? Now, logs are the opposite or the inverse of exponential. So a really important thing that's going to happen is you're going to take the log of both sides. Sometimes you can rearrange an equation beforehand, and if you can get the power by itself, which it is right here, then if we take the log of both sides, because what you do to one side of the equation, you do to the other side. What's really nice about logs is logs have a log law that moves an exponent out of the exponent area. That log law says if you have the log of a power, that exponent can come out in front, and if that exponent comes out in front, log 2 is a number and log 3 is a number, now it's really easy to get the x by itself. Log 3 over log 2. And I'm going to advertise this as this is, in my opinion, a method you should get good at. There are shortcuts for some of these, and I'll show you them as well. The problem with shortcuts is sometimes they're shortcuts because they work in certain situations, but they don't always work, so they're dangerous. They're like dangerous cuts. I don't know if that's a word. Shortcuts. Sometimes shortcuts is not going to be the best idea to do. This one has a nice shortcut. I'll show it to you. But it only works on some calculators, so it's, again, only somewhat useful. But you could also just change to log form, right? If this is exponential form, in log form, the base is 2, the answer is 3, the exponent is x. And if you can type this into your calculator, you would get the answer right away anyways. So that's really short. But I actually would rather you do what's in the black, because that's going to work more often. Okay, now looking at example 2. If I had this example, here is my power. And I'm going to show you that you have 2 techniques that you could go about doing this one. Okay? For me personally, here's technique 1. I would see, can I get that 3x by itself? Could I get rid of the 2 in front? Yeah, you could divide both sides by 2. So I'm going to split my page right here. And method 1, I'm going to divide both sides by 2. You could write it as a fraction or as a decimal, but 2.5. That gets my power by itself. Now I can take the log of both sides. I can take this x and move it out in front. This is slightly different than what I had in your notes, so I'm going to show you the notes one as well because it's really important. And now I could divide. Oh, and I want to show you something else super cool with your calculator. So I get x is equal to log of 2.5 divided by log 3. I'm going to take out my calculator, maybe. Yeah. And I'm actually going to write this in. And it comes out as a decimal, 0.834. Now what's really cool in this unit, which can be either really awesome or actually really disastrous for you, you're going to find out, is you will find out if you are right or not, which is really cool when you're right, and disastrous when you check and you're completely wrong. That's not as much fun, right? But at least you have the opportunity to check. So one of the things I like to do is after I get my answer, I like to store my answer, so above the on button is the store button, and just store it as x. And that lets me rewrite the original equation, which was 2 times 3 to the x. And if I push enter and this equals 5, I can do like the happy dance because I know I got it right. If it doesn't equal 5, I have Kleenexes during tests. You can cry. It just tells you you're going to have to do it again because something went wrong. Oh, now I'm nervous. Okay. Now you can be happy because you got it right. So it's really cool in this unit that when you're done, you don't even need to check the back of the book. I want you to get in the habit with whatever calculator. You can do this on a scientific calculator as well. Store your answer, plug it in, and see if you're right. Now, if you can get the power by itself, it usually makes your math easier. That's why I showed you that method first. But what's going to happen to most of you is you're going to get excited about using logarithms and take the log of both sides early. Not bad, it's not wrong. As long as you don't get tempted to break our order of operation rules. You know BEDMAS? You have to do exponents before you multiply. But I'm going to tell you that some of you are going to be so tempted when you see this. It's like 2 times 3 is, oh, I know 2 times 3. Your brain's going to be like, that's 6. Hey, that's 6. And you're going to be tempted to change that 2 times 3 to a 6 early. But that's not allowed because technically what do you have to do first? You have to do this exponent first. You're not allowed to multiply the 2 times 3. You're also going to be tempted. Oh man, this is like super temptation question. You're going to be tempted to bring that x out in front. But the log law says only when the exponent is to the entire thing inside the logarithm can you bring it out in front. Can you see if I bring it out in front, then I'll still have my 2 times 3 and I'll do the thing that's wrong, which is getting that 6. So instead, we first have to use the log law that is multiplying. And the multiplying log law says if you're multiplying inside of a logarithm, you can add. And now, this x could come out in front. This is a number, log 2, so I'm going to move it to the other side. I'm going to move that x out in front of the log 3. Move that log 2 over, and now I could get x by itself by dividing by log of 3. It's a different looking answer than what I had over here. I'm going to check on my calculator if it gives me the same answer in the end. I'm going to go fraction button. I'm going to do log of 5 minus log of 2 divided by log of 3. And I get 0.834, exactly the same as before. And some of you might be looking at this and going, oh, I see why they're the same, because what's the log law for subtracting? You could combine them to divide, and then you get your 5 over 2, which would give you your 2.5, exactly the same. Okay? But notice if you get the power by itself, if you can, there's no temptations on this side. Chances of you getting it right are going to be very good. If you don't, and you take the logs right away, you have to make sure you don't fall into temptation of that 2 times 3 is 6. It's going to be very tempting. You will want to impress me with your mental math skills. I know. You'll be like, oh, Mr. JR is going to be so impressed that I know that 2 times 3 is 6. Right? And then some people will do 2 times 3 and get tempted and still write 5, and I'll be like, oh my goodness. Mental math skills are bad, and you're doing the wrong log law, all at the same time. Could happen. But either way, we get the same answer. So sometimes, if you can get the power by itself, it makes your life a lot easier. But both methods are good. And in fact, it's really important that you understand the method on the right, because sometimes we get to questions, this one isn't that hard, but if we get to some, I can make the hardest one possible. See if our textbook has the hardest one possible. If not, I'll make one up just for you guys. Let's see. Yeah, well, no, they don't have, I'll make a hard one up for you. Don't worry. It'll work out. But we'll do these ones first, and then we'll do a couple more easy ones first before we get to the super hardest one. Okay? We're solving for x in exponents. We actually have two powers this time. We can't combine those together. The bases are not in the same inner column of a powers chart, so we can't do this without a calculator. So we're going to need to take the log of both sides. And you know how your calculator has a log button and a natural log button? You can either take the log of both sides, or you can take the natural log of both sides. Most students like to use log. I like to use natural log because it's one less letter to write. And that saves me about like 0.08 milliseconds in time. Like I'm going to save so much time here by using two letters instead of one. So I could use log or I could use natural log. And if I do this, this is an exponent, it can come out in front. This is an exponent to the whole thing, it can come out in front. So when your exponent is a binomial and you bring it out in front, make sure you remember to put it in brackets. Because that whole thing has to multiply by the natural log. And then since the natural log of 5 is a number, you can distribute here and you can distribute here. That gives me x natural log of 5 minus the natural log of 5 on the left side. And 2x natural log of 3 plus 3 natural log of 3. You know how I make my L's loopy like this, so you make sure that they're an L, because when you write them like this side on this, I've had, I don't know how many students say, oh, I don't know how to use the in. It's not an I, it's an L. It's for logarithm naturel. It's like Frenchy. That's why the L's first and the N's second. It's not an I. But there's people who say, I don't know how to use the in button. And then they look on their calculator and they can't find the in button. It's just an LN button. It is an L. Okay. So this type of example, notice that there are two different x's. And we want to solve for x. That's the whole purpose. So when there's two different x's, what we do is we put all of our x's on one side. So all of our terms that have x's, I'm going to subtract the 2x natural log of 3 on one side. And all of our terms that didn't have x's, so I'm going to add natural log of 5 to this side, on the other side. And when you have two terms with an x, that's a common factor. So the key thing, the key step when you have two x's is to factor out a common factor of x, leaving you with natural log of 5. If you take an x out of here, you'd still have the 2 and you'd still have the natural log of 3. And right now, if you look how many times I've written ln, you can see why, like, log was 3 letters. I've saved a letter so many times already. This is good stuff. And finally, we can get x by itself by dividing by the natural log of 5 minus 2 natural log of 3. And again, if you're like most students and you see that answer, you have no idea if that's right. Like, did I make a mistake? I have no idea. Does it look, how does your gut feel? Does that look like a reasonable answer? You have absolutely no idea if that's reasonable or not. It seems really unclear, right? There's no way that you'd be like, oh yeah, that feels good. So we're going to have to check it. I'm going to go to my calculator. I'm going to use my fraction button again. I add natural log. Let's scroll down here. There we go. Maybe I can see it. 3 natural log of 3. natural 3 natural log of 3 plus the natural log of 5 divided by natural log of 5 minus 2 natural log of 3. Double check that I wrote it in correctly. Then I'm going to push enter. Negative 8.345. I still don't know if your gut feels good about that or not. So I'm going to store it as x, and I am going to check. I'm going to go back to my original equation. And my original equation, right, we're going to have to scroll to the top here. 5 to the x minus 1 on one side. So I can check 5 to the x minus 1 is one side. I push enter and see what that equals to. 2.9 times 10 to the negative 7. And I'm going to check 3 to the exponent of 2x plus 3 on the other side. And if they're the same, we can do the happy dance, right? If we're wrong, that means I taught you something completely wrong, and we just wasted, I just wasted like 5 minutes of your life. And then like some of you are thinking, you wasted 5 minutes of my life either way. No, this is, okay, good. They're the same. We're all good. It's so nice that we can check. If the numbers are the same, and it's important that you store it as x with all the decimal places. If you only kept 3 decimal places, then you'd have to be content if the numbers are close, that you feel like, okay, I think it was right because it's close. But if you round early, they won't be exactly the same. So if there's x's on both sides, you're going to take the log of both sides. You're going to solve it through. And if you type this into your calculator with log instead of natural log, it'll give you the exact same answer. So in these kind of questions, those buttons are interchangeable, or writing it is interchangeable. Okay? You use logs in high school, and then once you get to university, they almost get forgotten completely, and it's all natural logs in calculus. So with that, we're going to go to example 3. Maybe. Computer is slow. Because example 3 has some more. And then I'm going to add a part D, which is the hardest one that I can think of. So sometimes what I do to start with is I put a box around the power, and I just do a quick check. Could I get that power by itself, or is it already by itself? It is already by itself. Life is going to be easy. This is on page, it's in section 5.7, example 3 on page 420. So for A, I would take the log of both sides, or the natural log. And that would allow me, with my log laws, to bring the x out of the exponent. That's the whole reason we use our logs, is because there's a log law that lets you pull that x out of the exponent, which allows us to solve. So now, I'm going to get log of 12 equals x log of 4, and I can get the x by itself by dividing both sides by log of 4. And I can take out my calculator, log 12 divided by, oh, maybe I can't do that. Log 12 divided by log 4. 1.792, I can store that as x, and I can check if 4 to the x is 12. And it is. Super exciting. Oh, I forgot to remember the decimal places. What were they? 1.792. Again, if it doesn't say what to round to. We go to 3 decimal places. Second question, same starting point. I'm going to put a box around the power. My power is right there. Before I take the log of both sides, could I get that by itself? Yes, question.
The question says do the nearest hundred.
Oh, yes. And that's also a really good thing to remember to do, is reread the question once you're done. I probably would have done that once I finished C and then went like, oh, it says to the nearest hundredth, so I would lose an E6 error for not changing it to 1.79. I can get the power. Can you see you could divide both sides by 3?
Yeah.
And that would get the power all by itself. If you can do that, that'll make your life easier. You'll make less mistakes. So now, when I take the log of both sides, or the natural log, okay, this is perfectly fine, what I did right now, but it's a little dangerous. You see that I took the log of both sides and I moved the exponent out in front all in one step. They will give you full marks for that if you don't make a mistake. It's dangerous because they actually give you 2 marks for that step. You get, on lots of exams, you get 1 mark for writing log of both sides. And you get 1 mark because it's a new concept for moving the x in front as an exponent. So that step would be worth 2 marks. If I do it all at once and I make a tiny mistake, I have a possibility of losing both of those marks. So generally, I would say, you know, take the log of both sides. Because if you forget the brackets here, you might lose both of those marks. I'd hate for that to happen. So you can do it all in one step, but you're like living on the edge. You're like, oh, make sure I take mathematical risks. Living on the edge. Here, the log 2 is a number, so you can distribute it. X log 2 plus log 2. Now I can move log 2 to the other side. And I can get x by itself by dividing both sides by that log 2. Can't cancel these log 2's out because adding and subtracting means those things are grouped together, and the only way we can simplify in a fraction is if you're multiplying and the factor is identical, just like in identities unit. So I look at this, I go to my calculator, go to my fraction button, and I type in log of 12 minus log of 2 divided by log of 2, 2.584. Thank you for reading it. 2.58 to the nearest hundredth. And now I'm going to check if that actually works. So I store it as x. My original equation was 3 times 2 to the x, 3 times 2 to the x plus 1. If this is equal to 36, I'm happy. Yes. I'm imagining a teacher who would always get those wrong early in their career and then have some sort of post-traumatic stress disorder from being nervous about pushing enter at the next point. Okay. So again, that one, not too bad. especially because we could get things by itself. Part C is another one of these with x on both sides. I'm going to just start part C on a new page so we don't have to. Maybe. Oh, there it is. So 3 and 6 are not on your same powers chart. You've got x as an exponent on both sides. We can't get any of those powers more by themselves. So we're going to take the log of both sides. I'll use log because I know you guys like it better. I want to use natural log. All those extra letters I'm going to write. But now when I take the log of both sides, this exponent can come out in front and this exponent can come out in front. So we're going to get x plus 1 has to be, it's a binomial, it has to be in brackets. And then the log of 3 is a number that can be distributed. So we're going to get x log 3 plus 1 log 3, which is just log 3. If you want to be lazy and just work on one side for a bit, you will lose 1 or 2 marks per question. So don't be lazy and don't be like, oh, I don't want to you have to rewrite so much stuff in logs. Just do it because it's not worth losing the marks. Like, oh, I just want to work on one side for a while, not ignore the other side. Yeah, you know who you are. There's those of you that are like, I like to be lazy when I'm doing it. I don't feel like I have to write everything down. It's going to cost you marks. You know who you are. There's quite a few of you in this class at times that, yeah, anyways. We have x's on both sides. So when you have more than one x, we always get both of our x's on the same side and all of our terms without x's on the other side. So I'm going to move the log 3 over, I'm going to subtract the x log 6, and then the key when you have more than one x is to factor out the common factor. And once you factor that common factor out, that allows you to divide. I'll scroll up. I'm going to type this into my calculator. This up so I can see it. Negative log, I used my fraction button. Negative log 3. Notice I used the negative sign, not the subtraction sign. Divided by log 3, subtract log 6. 1.58, so x to the nearest 100. And now I'm going to store this as x. And to check, I've got to plug in the one side and plug in the other side. So the original equation was, on one side, 3 to the x plus 1. And the other side was 6 to the x. Oh, I pushed enter so fast I didn't even have a chance to get nervous. And they're right. Feel free, if you check on a test and they're right and you're excited, like you can do fist bump during the test, I don't mind. If you let out a little squeal that's okay. Yes! Like it's supposed to be a test, I know. But it's exciting when you know you got it right. So, feel free to do that. Hopefully there's nobody that does really loud outbursts, might scare other people. Okay, now I said I would do one as hard as I could think possible. Are you ready for it? Solve for x. 3 times 5 to the 2x plus 1 equals 7 times 4 to the 3x minus 5. I don't even know if this is possible. I just made up a bunch of numbers. Okay? Always when you have x's on both sides, it makes it more difficult. Obviously, my bases are 4 and 5. They are not on the same of your powers chart. And we have extra numbers in front. I need to save letters. I'm just going to warn you. I don't know how much room you have. Hopefully, you've got all of page 421. And if you need to, we can keep writing. So we're going to use a lot of logs in this one. It's going to take some space. But we're going to start, and I'm going to use the natural log because I want to save a letter. I'm going to start by taking the natural log of both sides. And here, you're going to be tempted to put 3 times 5 together for 15. Not allowed. You're going to be tempted to bring the exponent out in front already. That's not allowed. The only way an exponent can come out in front is if the exponent is to the entire thing inside the log, but this exponent is just to the 5. It's not to the 3. So we have to use our log for multiplying with these blue dots there. We have to use that log first. So multiplying means, inside of a logarithm means you can add. Perfect. So now I use the log law and say multiplying inside of logarithm is same as adding. And now this exponent is to the entire base inside your log. It could come out in front. Same thing here. This exponent, entire thing inside your log, it could come out in front. So I'm going to get natural log of 3 plus. And when a binomial comes out in front, I have to put it in brackets. Now when you have those brackets there, if in front of those brackets or behind you in this case, that natural log of 5 is a number, you can distribute. The natural log of 4 is a number, you can distribute it. So I would get natural log of 3 plus 2x, natural log of 5, plus natural log of 5 equals natural log of 7. Distribute this, I would get plus 3x, natural log of 4, minus 5, natural log of 4. How many places do we have x's? We have an x there and an x there. When you have x's in more than one spot and you're solving, we put all of our terms with x's on one side and all the terms that are just numbers on the other side. So I'm going to move my x's to the left side. That's going to give me 2x natural log of 5 was already there, but I'm going to subtract the 3x natural log of 4. And on the right-hand side, I'm going to keep all my numbers. So I had natural log of 7 minus 5 natural log of 4. I'm going to move the natural log of 3 over. And I'm going to move the natural log of 5 over. And at this point, you're probably going, these are the hardest ones. They're just bigger, but all of the rules are staying the same. The same process is throughout this whole thing. What did we do when we got the x's by themselves on one side? I took out my blue pen. Why did I take out my blue pen? Because I was going to write factor in blue. Okay, if you tell me on a test you can't do this step because you forgot your blue pen, I will be mad at you. You still can do it even if you don't have the color blue, right? Okay. So we factor out that x. Now, factoring an x out of 2x doesn't leave you with an x. That's a mistake. Sometimes people think, oh, there's 2 x's, I took 1 out, I'm still left with 1x. No. Factoring out the x would leave you with a 2. The x is taken out. Factoring out the x here would leave you with 3, natural log of 4. equals. And this is where you lazy people decide you don't want to write anything because there's so much to write. Oh my goodness. You have to. It doesn't actually take that long. Most of the things that you think are super long to write in math are less than a half a sentence that you'd write in English. If you count letters, it's not that much. So don't be lazy. And now, the whole top part. Oh my goodness, I know, it takes so long to write out. Gets divided by the 2 natural log of 5 minus the 3 natural log of 4. Oh. This was super long. I have to admit, I've got some nerves right now. I'm going to type this into my calculator and store it as X. I'm feeling like 83.7% confident I didn't make a mistake. We're going to find out. I'm going to go to my calculator. I'm going to type in my fraction button. If you don't have the fraction button, you do have to put the whole top in a set of brackets. And then dividing, you have to put the whole bottom in a set of brackets for your calculator to do it right. But if you have the fraction button, your life is easier. So natural log of 7 minus. Notice how the natural log on your calculator automatically adds a bracket. So you have to always remember to close those brackets. Minus natural log of 5. 2 natural log of 5. Minus 3 natural log of 4. Okay? And we get our answer. So I can push enter. There's no nerves yet. 8.18. But now I'm going to check. So I'm going to store this as X. And I'm going to go back to my top of my question here. What was it originally? Move my calculator down so I can see down a little bit. Now the nerves come in. So we got 3 times 5 to the exponent 2x plus 1. And that's the first one. Now the moment of truth. 7 times 4 to the exponent. 3x minus 5. Yes! Okay. So you can get that. Did it get warm in here all of a sudden? I was like, oh. Heart was beating a little bit. But you can check it. And this is as hard as they can get. All right? The steps stay the same all the way through. We have to take the natural log of both sides. Oops. Here it is. We take the natural log of both sides. We use our log laws to get the exponent out in front. And these ones, because of the multiplication, are going to tempt you to do the things you're not allowed to do. Okay, so, right, if you get to the end and you check your answer and it's wrong, you're like, uh-oh, maybe I succumb to that temptation. If there's x's on both sides, you get your x's onto one side so that you can factor, and then you can solve. Okay, questions for practice. 7, 8, 10, and 12. This